In the next few videos, we're going to examine graphing rational expressions. We're going to consider vertical asymptotes, holes in the graph, and horizontal asymptotes. An asymptote is a line that the graph will get infinitely close to, but never touch. In this video, we'll begin by looking at vertical asymptotes. Vertical asymptotes, or vertical lines that the graph will get infinitely close to but never touch, result from values that make the denominator equal to 0. And we've looked at things like this before when considering restrictions on rational expressions. So here's an example. F of x is equal to 1 over x plus 2. Well, what values make the denominator equal to 0? Well, when x plus 2 is equal to 0, that's because x is equal to negative 2, just solving that equation. So this is going to be a vertical asymptote on the graph. The graph will approach the vertical line x is equal to negative 2 infinitely closely, but will never touch it. Remember that vertical lines have equations of the form x equals something because all of the points on a vertical line share the same x coordinate. Let's take a look at what the graph of that function looks like. Here, this dotted black line is not actually a part of the function or a part of the graph, it's the asymptote. It's the line x is equal to negative 2. And as you can see here, imagine there's an arrow on the end of the function. The function is going to get infinitely close to it, but it will never touch the line x is equal to negative 2. Let's take a look at a table of values to see why that's the case. On this table of values, I've included values for x that are close to and on both sides of negative 2 are a value that makes the denominator 0. And on the right-hand side, I've calculated the y values. So notice first that when x is equal to negative 2, as we said, the denominator becomes 0. We've plugged in negative 2 here for x, and we got a denominator of 0, which is undefined. So this is going to be our location of our vertical asymptote. Now, let's start out a little bit on either side of that vertical asymptote and get closer and closer to it in the x dimension. So if we start to the left of it at negative 3 and we move in towards the vertical asymptote, so to look back at the graph, what we're doing here is we're starting here from negative 3 and we are moving in towards the vertical asymptote. What we see is as we plug these values in for x and calculate the y values become bigger and bigger negative numbers. What that means on the graph is that as the x values approach negative 2 from this side, the y values get more and more negative, so the graph shoots off in this negative direction. If we look at this part of the graph, as we go from x is equal to negative 1 to negative 1.9 to negative 1.99, as we move in this way, what we're doing is approaching the graph here from negative 1 down towards negative 2 like that. And as we get numbers that are closer and closer to negative 2 from the right-hand side, what we see is that the y values again become bigger and bigger numbers. This time they're positive numbers. And that's why you see the graph shooting off in the positive y dimension, or up, as you get closer and closer to the asymptote from the right-hand side. So to show you the table of values again, you can see that as you get closer and closer to x is equal to negative 2, the graph is going to shoot off upwards from the right-hand side and downwards from the left-hand side. So vertical asymptotes result from values that make the denominator of the function 0.